Good day, everyone. Before we begin, let me ask you a simple question. Have you ever wondered why some plants grow healthy in one area but fail to grow in another, even when they given the same amount of water and care? The answer often lies beneath our feet, the soil.
That is why we developed a Python-based soil analysis program, a computer program that uses basic programming concept to analyze soil test values, evaluate soil condition, and provide meaningful results in a faster and more accessible way. Today, we will explain how our program works and how each Python features contributes to accurate soil analysis. For the feature 1, input, entering soil test values. The main function of this part is to analyze the physical properties of the soil. This code uses functions, input and output, variables, conditional statements, and return values to analyze soil characteristics and decide whether the soil is suitable for planting. For its feature, determine if the soil is suitable for planting based on its smell, structure, drainage time, and color.
Feature 2, Float, Converting Numbers. In this part, the code helps the user to analyze the chemical and biological characteristics of the soil. It uses codes such as functions, input and output, variables, comments, conditional statements, and return to determine if the soil is good for planting. It is designed to determine the presence of organism and plant growth in the area.
So for our feature 3, if, elif, and as conditional statement for our scientific evaluation. The core analysis of the program uses if, elif, and as statements. These conditions compare the soil values with standard ranges, determine whether the soil is acidic, bitter, or alkaline, and identify if nutrient levels are low, adequate, or excessive. This simulates real scientific decision making based on conditions.
So we have the feature 4, which is function. It is organized analysis to keep the program organized and easy to understand. We use function defined with def. Each function handles a specific task, such as analyzing soil pH, checking nutrient levels, and this makes the program more efficient, reusable, and it's easier to improve in the future.
Feature 5, Variables. Storing soil data. We use variables to store the soil test values entered by the user. These variables allow the program to temporarily hold data, pass information between functions, and use the values rapidly during analysis. Variables act as containers that make data processing possible.
Feature 6, Print Statements, Display Results. Feature, user can repeatedly collect cell data from different sampling locations and also can perform mathematical computations related to soil properties such as average pH, average soil nutrients, organic percentage, and total water retention. Part 6. In this part, it integrates all soil data and evaluates overall soil suitability using functions with return values and conditional statements. The program collects average soil pH, nutrient level, and organic matter percentage, then processes these values using conditionals to make a final decision. This part highlights the importance of modular programming in creating a complete and effective soil analysis program.
So this is the end of our presentation. This final project named Python Basal Analysis Program. Thank you.